Yes. So how is weather in Johannesburg? Guys, we have participants from South Africa with us. It's first time participants, so welcome them. Great. Anastasia, welcome. Okay, guys, so I suggest we start with this introduction. Before starting, can you please all confirm to me that you are hearing me and the voice level is not too high? Great. So, multi-comfort house designer, last version 4.5, which you will be able to download starting tomorrow. This is the last update, and following some of the requests from the participants, I took the decision to post it and to make a short presentation about the usage of this tool. What is it intended for, and what is the spirit? Because in the end, it's most, in my vision, the most important thing. So the tool itself, it's designed in an easy to use, or as easy to use as possible, to give you some good values, some good results, but also not to enter too much into the, let's call it, engineering part, which requires from you very laborious calculations and very laborious details and so on. Calculations are quite fast and reliable, and as a function, this is designed to give you some key energetic parameters for the building, which are linked also, which are calculated taking into account the local climate. How do you get this? In order to get this tool, you have to connect yourselves to the isover-construction.com, which is here. This is a database which works in parallel with this tool. So in this database, you will find even more construction details than those which are already present in Designer. And in order to get this, you have to register to this database, and then you can download the tool. Now, about the tool itself, by the way, how many of you have already installed it? Okay, Donko, we'll discuss about them. Thank you. Okay, so allow me to introduce to you the main features of this tool. So you have here the menu, which has several functions such as area, envelope, quality, summer, HVAC, calculation, output, and so on. You have here, in general, the part which is active and which is taking into account the results or the selection, the actual selection. There is a navigator, a fast navigator part, which allows you to which takes you step by step forward or backward. The navigation, once you are aware with it, you can do it directly from the menu. And here you will find the results. So this is quite simple, fast forward, without too many complications. Now, when we discuss about the simulation, as I already mentioned to you, this is intended to be easy to use, and in some cases you might not find the exact requirements that you would like to. In that case, you can approximate, and I will speak a little bit about this and how to make approximations with this, because the intention was not to allow you to calculate that one building is consuming, I don't know, 12.35 kilowatt hour per square meter and year, rather to give you an idea about what it goes and how it goes, what happens if you change the location of the windows, what happens if you have a ventilation with air recuperation, what happens if you, for example, select a certain type of construction details, or if you select, I don't know, some kind of airtightness of the building, and you do the building quite not airtight. So for this I have prepared a little bit just as an example what would be and how to analyze and look at these buildings. Basically, this is a building composed of 3 tronsons: first tronson, second tronson, and third tronson. It's a destination residential. Destination will be located in Brest, 3 floors, north-south orientation, so quite simple. Volume for each of the tronson is 10 by 10 with a 9 meters height, so 3 meters per level. The windows are all placed on the south facade, and each of the windows is 1.5 meter by 3 meter. And here you can have some kind of shading. So this would be the general status. Now, what would you say in terms of simulation? What should we simulate? Should we simulate one apartment, all tronson, or full building in terms of energy efficiency? What would be your opinion? Well, let me just say that in principle all of you are right. Yes, Donko, they are connected, and you would simulate in principle the full building, taking into account that you have a central heating system. But if you do not have a central heating system, and you assume that this it's one house, and this it's another house, and the third one it's another house, so you have only one person living here, and one person living here, and another person living here, then in principle you would simulate only one of the buildings, because in this case you can consider to some extent that the performance of the building should be linked to the heating device. But in the end you can do one or another. I would suggest you go for the whole building, because this would be much easier for you to simulate it. But if you choose to simulate, for example, only this part, then basically the calculation tool, what it will do in the last version, it will not take into account any heat transfer between these 2 apartments, because it will consider that the other one it is heated at the same level. In the very advanced softwares, you can simulate with a higher accuracy, let's say, and then you can take into account here a lower temperature. If you say that here it would be 21 normally, then you would say that in this case, if I have some wall towards a neighbor, then I would take into account, I don't know, 15 or 16 just to be covered. So you have the possibility of going by tronson, let's say, or you have the possibility of going by full scale building. And I would say that the full scale building, it's much easier for you to simulate because it doesn't go, you do not go too much into the details. There are, however, a certain number of details that you can select through your simulation, which will already influence in one way or another your calculations. Does it make sense what I'm saying up to now? Okay, good. As you can see, this is a quite simple building. I haven't used any, I don't know, special forms that you can select and do. You can, however, always approximate. If you have some kind of a building which is, let's say, a pentagon, or which is I don't know, some kind of a circle, let's say, then you can always approximate it to a simple form, and this way you solve the problem of having too much complex surfaces. Of course, you can. The tool itself allows you to go to a very detailed analyze, and we have been doing that, and we have analyzed it against some other tools. It's quite reliable, but I don't think that the purpose of this tool for you at this point is to simulate that the living surface it's 12.1 or 12.15 meters. So again, if you have a more complex form shape, try simplify it, try approximate it to the closer to a simple usage. Now, allow me to ask you one question. If I consider this to be a section, my mouse is not going very well, a section through the building, and if this, it's a, let's say that it's this one, and here I have the external walls. Now, my question to you would be the following. If I take into account as surface, when I'm doing the calculation, I take the full surface, or I take only this one? Okay, so when I'm going to simulate my building and I'm going to analyze the envelope, I'm going to take the full, oops, my mouse. I'm going to take and to put, in principle, I should put the full surface of the building. However, when I'm speaking about the area to which I am referring, I'm taking into account only the usable surface. So basically, there is already, from this point, when you are simulating, a slight difference. If you take into account and you analyze the full length of the building, the final, the exterior envelope, then you obtain one result. If you divide these results not by the footprint of the building, but by the usable footprint or usable area of the building, then you obtain another result. We haven't been pushing too much this, and we haven't inserted it like this, because in different countries the legislation, it is quite different, and in some countries they are using slightly different approaches. For example, instead of calculating with the external limit of the envelope, in some countries they are taking into account the middle of the wall, and the results might vary. But however, just to give you an idea, when you simulate in principle, you should take into account the external dimensions of the envelope, and you would put inside the livable surface, that surface that you are hitting, not the surface that you are not hitting, because what you try to analyze is how much energy you consume for the heating. So if instead of these windows I would have some balconies, and if those balconies are outside the heated envelope of the building, I should not take them into account. Now, first selection that you would have to do is to take a look at the information related to the country, and the selection of the country allows you to go and to select a choice for the climate. In this case, the selection is Belarus, and if you go and select, if you go and check the climate, you will see that you will see there are two climates available. One is the climate of Minsk, and the other one is the climate of Brest, which are both available. You will select in this case Brest because the location of our project is Brest. Now, the second step to do within the course of the project is to look at the insertion, and here you can put the heated space area. You can either put it directly by inserting a living area and adding some estimation. You can choose to put 3, 4, 10 living areas according to how many levels you have. If the levels are different and you want to go very much into the details, you can select to insert for each of these levels a description of it. Then you will have to insert the volume, and you have the same option for the volume. As you can see, here is the heated volume. So you put the first volume, which in this case could be the volume of this apartment, and then, or this floor, sorry, to be more exact, the level of this floor, and then you can select to put another volume or 3 volumes, and you define each level or all of it as a volume of a heated, I'm speaking about the heated volume. And then you come to the main application, let's say, where you have opaque elements, and you can select here wall against air, you can select slab against ground, or you can select wall against neighbor. According to your selection, you will be asked to insert a length and a height, or if you choose to, if you have some kind of shapes which are not necessarily rectangular and to which you cannot apply this multiplication, you have here also the option of adding some separate values. So in principle, you have to put the surface of the external walls. If I would look at this one, for example, then I would insert the volume, the external surface of this wall. Then I could insert the external surface of this one if it could be independent. So instead of 3, if I would have 1, I would just put the values for each of these. If you have any questions while I'm presenting you this, please do not hesitate to stop me, and we can take an answer. Then you can have the option of selecting a roof flat, or a slab against ground, or a slab against an unheated cellar. There are several options that you are having here, and with which you can play with this tool in order to define what are the main characteristics of your building here. Also, a very important aspect of this selection is the fact that you have to link or to give a certain orientation of the walls, especially. The walls can be oriented on these windrows where 0 represent north, 90 degrees represent east, 180 represent south, and 270 represent west. So my first wall against air, it's towards north. My second wall against air is towards east. My third one is toward south. My fourth one is towards west. And when I do this, I'm sure that the building within the software, it is taken into account according to its cardinal points orientation. Then you have the option of adding windows. Of course, windows are needed, and you can select to, or you can choose to do this in several ways. You can select to individually input each of the windows. Let's say that I have here 1, 2, 3 windows, then I'm putting window 1, window 2, window 3. Or I can say, if I know that the windows, let's say, are similar and I have a rough idea of the windows and I don't want to go too much into detail, I can also approximate them. Of course, if you individually input them, and especially when they are on opposite facades or on this facade, it's better because you have the option of playing also with each of the window and the type of the glass that you are going to put there. If not, it will be a much rougher estimation of the behavior of your building. So, sorry, we were here. These windows, each of them, they are attached to a certain exterior surface. You can attach a window to a wall. You can attach a window to the roof in case of the flat roofs. This, it's also giving the fact that you are linking the window to a wall. It's giving to that window the particular or cardinal orientation of the wall. Therefore, the tool will be able to calculate and to estimate the solar gains through that window furthermore into the calculation. Last but not least, you have some doors, and you can take into account, for example, if I consider in this case that we are showing, okay, the door is not represented, but if I consider that this segment, the stairs are also heated because this is a high-end construction, so the people living there, they would like to have a good quality. Then I can simulate a door on the north facade, and this would be the door that is part of my envelope. I would not simulate each of the particular door of the entrance to each of the apartments. Or if this, instead of 3 apartments, it's one apartment with 3 levels, then again the same thing, I would simulate the entrance door and not the intermediate door of each of the levels. Once I have done that, I will see, as well as I'm going to see for each of the area here, project data, area input, I'm going to see that there is a green button here which is appearing instead of a red one, which means that I would have fulfilled the minimum information that the software requires so that it can go further. Then I have the possibility to select between passive house certified systems or independent details. The passive house certified systems, there are systems which have been analyzed by the various by an external institute, and that are from thermal point of view thermal bridge free. So you do not need to take care of the thermal bridges. However, you do not have too much option to play with these details. These details, you just can use it as such. And in some cases, you might find out that the details that are there are not close to your details, and that perhaps, let's say, you would like to see what happens with other details or with different allocation or with another type of construction. In this case, what you can do is to use the independent details, the second one. This second one allows you a higher level of flexibility in terms of simulation. So once you have selected it, you will be pinpointed to a detail like this one, where you will see different circles which are in fact identical with the selection that you have made here. So you will have slab against ground, you will have wall against ground, we'll have wall towards neighbor, and so on. And when you are going to click on one of them, the tool will open, for example, in this case, roof flat. It will open a selection in which you have in the first part a specification of the detail. You can see it a little bit higher. Here you have a certain library with a number of construction. And here it will be given to you some key figures. So for example, the U value of the construction, and last but not least, you have the option of selecting this construction. You can either select it for the whole flat roof area. So if you have defined only one flat roof, then you can select it for all. If you, let's say, would like to be even more closer to reality, and I don't know, for some kind of strange reason, this roof area is different in terms of thermal conductivity than this one and this one from this one, then you would have the possibility of introducing all three of them, and then you also have the possibility of selecting this construction only for one type of, or only for one part of the one component of the roof, of the flat roof. So if you insert several components, if you have, I don't know, 10 types of walls that have been introduced, then you have the option of selecting individually for each of them the U values, or you have the option of selecting one U value, one type of construction for all of the values. Is it clear up to here? Great. Now, why it's, I would say, for in the beginning it's more interesting to go with this type of construction, because you have here the option also of playing a little bit with the thicknesses of the insulation, and this way you can adjust a little bit your construction, your U value, or actually a little bit more. You can adjust this construction to other value. So let's say that you are having some type of construction that you will not find here, because it's impossible to define all construction typologies, and even more, we wanted it to be quite a fast tool. Then what you can do is to say, okay, I know that I haven't found my construction. I know that my construction is about 0.30 in U value. Then what I can do is that I go to the independent details and I select that thickness of insulation, which will allow me to obtain a U value of 0.30. And this way I'm going to do my simulation according to the construction detail that I have chosen, but simulating it not with the picture itself, but rather with the U value, which is the correct one. So if you do not have find a detail, it might be so, because there are only a limited number of details. What you can always do is that you play with the independent details and you select in your simulation a new value which is closer or as close as possible to your real construction. And this way you are sure that the simulation itself will give you the results that are according to the reality. And this you can do for all of the construction details. When you have selected all of them, you will have here the value. For example, if I in this case I have selected this value, and the tool is showing me that for the flat roof I have a value of 0.11. Then I would do it for the walls, then I would do it for the slab against ground, and that moment my green button will turn red, my red button, sorry, will turn green, and I can go further. And the next, yeah, I forgot about it. So you can see here how you can play. So this is a picture from the detail that we are speaking. In the initial state, the selection is at with 18 centimeters, but I have the option of going up to 20 or as low as 0 centimeters of insulation, and then instead of 2 layers of 18 I will have only 1 layer of 18. This would allow you to play with it. And then you can also see here, for example, this is a selection from the when clicking on the external wall. So you have a selection or library with some external walls, and as well as you, for example, this is slab against ground, you have a selection towards detail with slab against ground. So if you do not find something, because as already mentioned, this is what the intention was, not to make you work 2 full weeks on the simulation, but rather to give you an idea of what are the implications of the different architectural gestures that you take. You can always approximate, and you have this option of playing quite close with the values. Any questions? Lian, now you do not have to present the full calculation to the poster. You will basically not have place to do all the calculation. Basically, at the last page of at the last slide, you will see you have this where you have all the results, and you just can put this part with the overview palette on your poster. Now it depends also from country to country, as in some countries you might be required to present let's say the full calculation. In this case, if you click on the output, you will have the option of saving this in a PDF form, and you just can have it printed on a paper and just deliver it with your project. You are from what country? Okay, so as far as I remember, the courses in Belgium, they do not require the full calculations. They are just requiring you to show the overview palette. Nevertheless, just to tell you, it is very simple to check if the results are coherent. So if the results are not coherent, they can be seen very easily also from the overview palette. Okay. welcome. Please check again with Amélie Dumont exactly the requirements, and well as with your teacher, exactly the requirements for your national stage, because each national stage has slightly or can have slightly different rules regarding the requirements from the university. For the international stage, you would be required only to put on the poster the overview palette, or if you select to do more, that it's up to you. This is the minimum, let's say. It is very well. It is also very well explained in the task. In the task, you will see a picture with the minimum requirements in terms of calculation. Okay, let's go further. Now, as regards to the windows, you have the option of selecting the windows and the doors. There are slightly less options for the windows, and you cannot play with the different thicknesses and so on. But again, try to select the one which you feel that is closer to your intended design. I could have there about, well, normally you can find in some software up to 100 or maybe 200 types of windows with different G values, with different U values and so on. But then that would not help you in the end too much, because you will just select them. Important would be that, okay, you see the difference between a single glazing and a triple glazing. You see the difference between a glazing with a higher and with a lower G value. As well as you can see the difference between a bed drawer or a slightly better drawer. And here again, you will be asked, as for the walls or for the roofs or for the slab, you have the opportunity of selecting, for example, this type of double glazing for all the windows, or only for specific windows if you, for example, have defined 10 types of windows in your project. The next slide that you will see, it's a summary. And in this summary, you will be pointed when you want to deselect something or to delete something, you will be pointed to this one, and you say, okay, I would like to deselect or to delete, as you prefer, the flat roof, if it is one. If there are 10 types of flat roof, you will see that this is attached. You can see here that this type of detail is attached to the flat roof number 1. If you have here 10 types of flat roof, you will have 10 details, like you can see here below, where there are several details of wall. Just scroll down and you say, okay, my flat roof number 9, it's not the right one, I deselected it. Then I go back with the navigation to the library, or I can select it directly from the envelope, and I select another detail. So this is basically a overview of what type of details you have selected and you have put it there. Up to here, I would say that this would be the most time consuming, if I can say so, although this can be done in a matter of 15 minutes, maybe 20. The utmost time consuming of the tool. The rest, it's even more easier than what we have been discussing up to here. So the next two are linked to the airtightness and to the thermal bridge. This is the selection of the airtightness, and you can select a very airtight building. In terms, this is expressed in values of N50, which means how many volumes does a building exchanges with the exterior through the cracks at a different pressure of about 50 kilopascal, which is more or less equals to a wind of 30 kilometers per hour. So this N50 tells you how tight your building is or it's not. It's like you would say, if you do a pro construction, it's like you would have all the time window open on the envelope, and you just warm the external air. So in principle, for a multi-comfort house, you would try to reach an N50 of about 0.6. Of course, at the moment of the simulation, you don't know how much it will be. You say, okay, I would like that my building would be quite airtight, and I would say I'm aiming for a N50 of 1 or of 0.8 or of 0.6. After the building is constructed, you can also have the measure of the value, and you have the exact one. And this can be done. There are some standard blower door tests which are done in order to evaluate this. That we have put this here so that you can take it into account and you think about the airtight of the envelope, the airtightness of the envelope from the beginning. And this has also an effect all over the energy demand and the cooling demand. And the next, the next one, it's about, yes, Miguel, no problem. This will also be uploaded on the website of the student contest as all the other presentations have been uploaded. The second step is to say, okay, is this construction a thermal bridge free construction? So in case you will use here the first option, the certified system, then you will be automatically have automatically selected a thermal bridge construction. In case you are not having this, then the system will require that you click yes, although it is not, because to calculate this would be extremely complicated. So to calculate each thermal bridge, so the tool, it gives you a value in the case that you will design this detail without thermal bridges. If you do not do, the final result will be worse, and the extent of these thermal bridges can go from very small influence to very high influence. So as this tool, it's not a tool for the calculation of thermal bridges, and as in each country the legislation is slightly different, and you have full catalogs with hundreds of calculations for this different details from which you just pick a value. We say, okay, please be aware that this is not calculating your thermal bridges. The results are taking into account a construction or an ideal construction which is thermal bridge free, and if you are going to obtain a result of 20, it's most likely that you are going to be towards 25 or 30 if you are using thermal bridge, if you are using the independent detail and you are not taking care about the thermal bridges. Okay? Good. Lian, do you want to ask something? Now, one step further. Great. Super. For the shading. Now, for the shading, you have two options. You have either the option of selecting average shading and then you just go further and you just make your simulation. Either you can select, okay, manually enter shading data. And if you select that, the tool itself will provide you with several types of shadings, geometrical, from neighboring buildings and so on. You have the option of selecting for each of your external walls or each of your facade the type of the shading generated by, let's say, for example, geometrical situation, or a little bit lower you will have the option in which you will be asked to put the shadings from 3, or you can be asked to put the shading from the window reveal. So the tool will try to approximate as much as possible, as close as possible. This is not a scientific tool. This is a tool to allow you to feel the different influences, and the result will be transformed here in the shading summary. This way will allow you to, it will allow to the software to calculate the different solar gains. Sorry. Then you will have the possibility of selecting the summer shading facilities. Now, beside the geometrical situation, or the fact that you are shaded by some kind of tree, you can always select some kind of summer shading facilities to help you in the situation that you are having overheating. In some climates you will have overheating, in other climates you will not have overheating. This will also depend on the type of windows, how large the windows are, on what direction, on what facade they are installed, and so on. So this is also allowing you to say, okay, I might need a little bit of sun shading just to make sure that there is not too much overheating in my building. And one more option that you are having here is to play with the type of ventilation that you would like to have for the summer. So let's assume that, I don't know, for the summer you would like to have some kind of night ventilation, and you are having here some 5 options of opening a tilted window for 1 hour, or opening a tilted window for 2 hours, or for 12 hours, or fully opening the window 1 hour or 2 hours. This you can also see with this, playing with this, you can also see what kind of influence will have the fact that you think, oh, okay, I'm not going to put any kind of summer shading, but I'm going to have recommend to the persons living there to tilt their windows in the evening 2 hours. Now, would that help me in terms of overheating? Will I have sufficient ventilation to avoid having temperature above 25 or 26 degrees or not? This is going to be told to you by the calculation tool. And with this, we are almost close to the end, because we are getting to the key figures of the forced ventilation and heat recovery system. So you can have here a system in which you have ventilation with heat recuperation, and you can select here yes, Donko, timber, it's light. However, the effect, it's not so drastical in this simulation, because the thermal inertia, it is simulated, but it's only to a certain length taking into account in the final calculations. So there are some factors which are taking into account this. You can play a little bit with the massive against the light, and you will see that in some climates the results are not very drastic, while in other climates you might have some bigger differences between the two simulations. Okay, so about the ventilation, you can see here again it's the same principle. There are very simple 6 or 7 options for the ventilation. You can either choose no ventilation and see, or you can choose a ventilation with heat recuperation, which is also making heating. And you have the efficiency of the system that you have selected, as well as the efficiency of the subsoil heat exchanger, which is selected slightly below. Now, once you have been selecting all of this, you just have to click calculate, and you will have the specific annual heat demand, and the second, in this case, it's about 230 kilowatt hour per square meter in years, which is slightly high. What should we obtain for Brest? What is our target? Good. Now, Donko, 15 or less, correct. What can we do to improve that, Donko? What would be your idea? Okay, tell me. Let me see, I don't know, maybe. Might be, yes. Yes, you are right. This is the first thing that you should do. You should check here the area. In this calculation, I put it wrong. So you should calculate this according to the and check first of all how clear are the results, and most of the time the big differences you can obtain are due to the small mistakes of calculation. Yes, the area should be yeah, the area should be what is the area there. In this case I have put it in 60, although it should have been 100 in the simulation. I mean, coming back to the simulation, you always take a look at what you are simulating, and you take this into account. Okay, great. Now allow me to go further. We were here. Then, for example, what you can do is to say, okay, let's take a look at the heating. And at the heating, when I was selecting, I was having a rather poor ventilation system with heat recuperation, which was slightly, if I remember correctly, it was a version of 70% rendement. And if I would select, for example, one with 95% rendement, then I would be much better. As you can see, I'm already at 40 from 250. Not all of it it's coming from the ventilation, because a part of it, a big part, it comes from the fact that we have been correcting it, the living area. Instead of 60, we have put it at 100 here, and multiply it with 3, that gives you 300 instead of the initial one, which was 60. Yeah, so I have been in the initial calculation, the area was under evaluated by a factor of 6. So once you play a little bit, you start to understand what kind of things you can do. For example, if I'm not fully convinced about this 41, then what I can do is that I go to the envelope, I'm selecting my independent details, and I go to the summary. And there in the summary, instead of selecting that type of less performant windows, I can play with a much better windows, and by selecting, for example, 111 here and here, you will see the result. In the end, I will decrease my my final values to even higher. So coming back to the introduction, the tool, again, it is here to provide you with some ideas of what it happens when you select different, or when you make different gestures. If, for example, you would put all these windows on the north side and no windows on the south side, your heating demand of the building will be much higher if it is in an, let's say, northern hemisphere. If it is, however, in the climate where you will have rather mild climate and where there is not so low temperature but rather high temperature, then in principle you will put your windows on the facade opposite to the sun to minimize your solar gains, so that you do not get overheating, because cold climate, or during the cold period, you will not have such a big request for heating. For example, if you go to Spain, to the south of Spain, then there the winter is quite mild, so you do not have a lot of need for heating, but rather in the summer, if you go to Valencia, you have 40 degrees. So if you put all your windows to the south and you did not take into account any kind of shading due to the design that you are doing, or due to the existing situation, or if you don't have either, you have not taken into account any kind of summer shading facilities, then you will end up with a building which is perhaps not consuming anything for heating, but which has a huge overheating problem, and then again the people that were going to live there will not be happy. That would be very briefly from my side. I invite you to download the tool and to play for the beginning with a very similar, with a very easy cubic form, just to play around and to understand a little bit the principle. I can tell you that in a matter of, let's say, 30 minutes or 1 hour, you should be quite at ease with this. And if you have any kind of questions, please do not hesitate to write to us and to ask. We'll try to answer to you as soon as possible. So this would be my final word on the presentation. Do you have any kind of questions? Yes, Donko, please do. Now, if this, okay, please please write your question, and then I will answer. Okay, so what you can do is the following. If you consider that, again, here if this would be it would be a functioning as a full building, then you can simulate the full building and analyze it as such. You have also the option in this last version to say, okay, I would like to simulate only one tronson, and assume that, in the case that this is one house. Okay, just 1 second. So this is one house, this is another house, and this is another house, and each of them, they are having independent heating devices, then you can simulate it taking into account wall towards the neighbor, and you will find this option in the below the walls towards air. But I would say that you can go for both of them. I would prefer to go for the full building, for the reason that it's slightly easier to simulate. You don't enter into many details, and most of the time you have some kind of centralized heating system which is applied, at least in Brust. Borshon, tell me, how can I help you? Well, you have two options here. This is not. This is one of the situation which is not specified as such into it. What you can do? Either you can consider this as a wall towards neighbor, and basically the tool will consider there is no heat transfer through that area, or you can take into account this by saying, okay, I am sure that here it's going to be a little bit of losses, but not as much as towards the exterior. So you can just simply take it into account with a higher or with a lower insulation, depending on what you have on your walls, and you just simulated it like this. Otherwise, this in some tools it can also be simulated, but I would have to ask you what is the surface there. Should we take into account the 10 degrees or 15 degrees or so on? So again, the scope is not that you calculate at 10.5. This is more to learn the different gestures which you can have. Not sure I'm following. It's a 32 square meter surface. What do you mean? No, I said that I explained to you that you have two options. Either you can consider this as a wall towards neighbor, and you can say that you expect that you are going to have there no heat transfer. Either you can just take it into account as a wall in terms of energetical simulation. You can take it into account as a wall towards the exterior with the same amount of insulation as towards the exterior, although there you know that you are not going to use these construction details. In one case your results will be higher, in the other case your results will be lower than what you have simulated. Don't worry, c'est pas un problème. Ça marche. De rien. Guys, any other questions? Okay, so the tool will be available for download, the last version starting tomorrow. And also I recommend you to check also the website of the contest tomorrow, as I'm going to upload some more information, as you are entering your last 2 months before the final event. We got some new information from Breastmare related to the transportation area and so on. So have a look at isover-students.com, get the link and register to isover-construction.com so that you can get the tool. And if you have any kind of question, please do not hesitate to ask me or the responsible Isover team in your countries. I wish you all the best, and looking forward seeing you at the international stage in Minsk in 2016. Yeah, hey, okay. Thank you so much, Abuai. Take care, guys. Thank you so much again. We will upload also this video tomorrow on the website. Bye bye.